So yesterday we reviewed how to factor polynomials basically, right? How to factor them in a very basic way. Just stuff that you've probably seen from Algebra 1. You saw it again in Algebra 2, and tough stuff, so we had to practice it again yesterday. We're going to continue factoring today, but what I'm about ready to show you today you probably didn't see in Algebra 1 or 2. It's how to factor polynomials that don't fit what we're used to dealing with. So, you know, if it's maybe the box doesn't work, or maybe it's not a difference of squares, but it can still be factored. All right, we're going to learn how to do that. And what comes into play there a little bit is that long division and synthetic division that we learned. I think it was, what was that, Monday or Friday? I forget now. Anyway, so that's the goal for today. All right, so let's review factoring really quick. So we got a trinomial there. I want to find the roots, let's say. So I set the y equal to 0, right? Then we factor it. We set each factor equal to 0, and we solve. Okay, so here's what I want you guys to notice. Whatever this root is, if you know the root, then you know the factor. It's just going to be the same thing, but with the opposite sign, right? So here, since my root is -1, the factor will be x plus 1, okay? So that's the factor theorem. I think I might have printed that for you on your little sheet. You guys see something on this that's the factor theorem? You do? Okay. Yeah, there it is. So if c, let's say that c is a root of your polynomial, then x minus c is one of the factors of your polynomial. Okay? So let's go ahead and begin here. So what we're going to do is this, the box method's going to fail. I'm pretty sure of it. Let's see. I'll try it really quick. The box method does not always work. I'll demonstrate that for you guys really quick. X cubed minus 2x squared minus 5x and 6. Okay? These have what in common? X squared, right? These have a 1. These have an x. And these have a 2. Since these are both negative and this is positive, these would both be negative. Do you guys see where this is not working? There. That's no good, right? I couldn't take a 5 out because it didn't have a 5, but there's no way for me to get a 5 there. Sometimes the box method just doesn't work. Okay? That doesn't mean it can't be factored. The box method, what it does, is it's only good for giving you factorizations that result in 2 binomials. But couldn't it have been a trinomial and a binomial instead? The box method wouldn't be able to do that for you. Okay? So what we're going to learn today is a more complicated way to factor polynomials that are a little bit more difficult, and they kind of go outside what we're used to. So first of all, we're going to use the rational root theorem to find all the possible rational roots. So this is something that we learned either on Tuesday or Monday. What we learned on Tuesday or Monday is that if you take all the factors of this number and make a fraction out of those with the factors of this number, you have a list of possible roots. Okay? So let's do that. What are the numbers that go into 6? 2 and 3. What else?
1 and 6.
1 and 6. And then what are the numbers that go into 1?
1.
1. A lot of times you'll find I just try to be nice and make that first number a 1, because then you don't end up with a lot of fractions. So what we do is we do these numbers over these numbers. So 1 over 1 would be 1. 2 over 1 would be 2. 3 over 1 would be 3, and so on. And don't forget, they could be positive or negative, and we don't know which. Now, do you guys remember how you can tell which one of these are actual roots? Plug it in. And what should happen when you plug it in? It should make 0, right? Now I'm going to save us the trouble of that today, okay, because I don't want to spend any more time on that. So what I'm going to do is I'm going to tell you what one of the roots is. So I went through the work already for you. I plugged them in. I found one of the roots that works. And one of the roots that works is x equals 3. So go ahead and write that down. Fill in that blank. Now, if you guys were to go through and start plugging those in, you would find that when you got to 3, if you plugged in a positive 3, it would make 0. Okay? Yeah. Mm-hmm. So far we haven't done anything new. And as a matter of fact, this whole day we're not really doing anything new. We are really just putting together things that we've already learned to go a little bit further. Yeah.
Can you repeat what you did for A?
A. Yeah, so what you do is you find all the, I'll pause real quick for the details. All right, so anyway, so here's our possible roots, and you guys hopefully know that you plug them in until you find one that makes 0, and I did that for you, and I'm telling you that one of those is 3, okay? Now, we're going to use the factor theorem that I just told you guys in the last slide. If 3 is a root, then what's the factor that goes with that 3? X minus 3. That's one of our factors. So in other words, if I were to factor this thing, break it apart, right? One of the factors would be x minus 3. Okay? Now here's the thing. If you know one of your factors, what you can do is you can divide that factor into that polynomial to break it down to something more manageable. Okay? Just like this, if I told you guys that, let's say, like, when I give students a really big number, like 126, and I say, we'll break down 126. What do we usually do? We start by looking for something that's really small and easy that we know goes in there, right? What goes into 126? 2. So the first thing you guys start off with something easy. Okay, I'm going to divide it by 2 because I know 2 is one of the factors. So I'm going to divide that in there, and then I'm going to get 63. And then we're like, oh, I see the light. It's 9 and 7 now, right? You didn't know 9 went in this before, right? But now that you got it down to something smaller, you do. That's exactly what we're doing here. Huh?
Oh, never mind.
Good. I'm glad I wasn't wrong. That would be embarrassing. All right. So anyway, so let's review where we are again. Find your possible roots. Plug them in until you find one that makes 0. You only need one, because as soon as you find one of them, you can turn that into a factor and then divide it into your polynomial to break it down to something easier that you'll be able to factor using our old school methods. Does that make sense? All right. So that's the process we're going through today. It's a 4-step process. Rational roots, find a root, turn it into a factor, use division, and then we'll factor it completely. All right, so here we go. We're going to divide this polynomial by this factor. So I'm going to need some space for that. What was the polynomial? Oh, it says synthetic division too. That's the beautiful thing about it. So what was my polynomial? It was x cubed what? 2x squared? And then? Okay, thank you. And then we're dividing that by what? X minus 3? That was our factor. Okay, so check it out. Synthetic division. What goes here? 1, just the front number. Next? Next? And then what goes in the front? Change the sign, right, of this last number over here. And over here, this is where our remainder is going to go. But if something's a factor, you shouldn't get a remainder. For instance, 3 is a factor of 12. If you divide 3 into 12, do you get a remainder? No. Same thing here. We should not end up with a remainder if x minus 3 is a factor. So let's go ahead and see what happens. Bring down your 1, multiply, add down, multiply, add down, multiply. Yay, no remainder. That means we did something right. you have a remainder, either you did your synthetic division wrong, or you picked a number that wasn't really a root. Okay. Okay. So what's the point of this? Well, what's one of my factors, you guys? It was 3, right? So there's one of my factors, right? And when I divided it into here, what was left? X squared. 1x squared, right? And 1x minus 2. So I just factored it. Okay? Hey, now okay. So now that I've got it factored, let's go ahead and see if the box method works. I think it's going to work. Okay? But there's the idea. So before I go any further, I want to review what we did, because I know this is a lot to take in. So here's the idea. Ready? Find the possible roots. Plug them in until you find one that makes 0, so you have an actual root. Turn that root into a factor, and divide that factor into your polynomial so that you end up with something simpler to work with. Okay? So let's go ahead and factor this. I'm pretty sure the box method's going to work for us here. Top left is x squared. Bottom right is negative 2. What times what makes x squared? X and x, right? And what times what makes negative 2? 2 and 1. What combination would give me my middle here if the 2 was positive? If the 2 was positive and the 1 was negative. So there's that. So now we have x minus 3, right? That's from our first few steps. And this guy just broke apart into x minus 1 and x plus 2. So our box method at the beginning failed us. And the reason the box method at the very beginning of the problem didn't work is because this thing didn't break down into 2 binomials. It breaks down into a binomial and a trinomial. And the box can't do that for us. Okay? So we use this other strategy. Find the roots, turn them into factors, use division, and then you've got something tinier that you can work with. Okay? Okay, so here's one for you guys. Now, usually, if you see one with 4 terms, what would you do at the very beginning if I asked you to factor that? You do the box method. Or you want to look for a GCF first, right? But I'm going to tell you right now, let's not do that, because I'm going to tell you the box isn't going to work. So when the box doesn't work, this is how we start factoring. So I want you guys to start with A. I'm going to give you like maybe a minute and a half. Do that. Check your answer with a neighbor. I'll call on you and share out your answers in a sec, okay? Maybe a minute, maybe not a minute and a half. Sit, Lolly, did you get part A yet? Okay, good. I like 1, 2, and 4, but 8 won't work. But 1, 2, 4, and not 8. And don't forget, they could be pluses or minuses, so you don't want to forget your pluses and minuses. So it's not 8 because the only numbers that go into 4 are 1, 2, and 4. And then we're dividing them all by 1, so there shouldn't be an 8 in there. But my next question is going to go to Edward. Edward, how can I tell which of these are actual roots? Because these are only possible roots. That's right. Good. So you just plug them in, and if one of them makes 0, you're going to stop there, right? And you're going to turn it into a factor. But I'm going to save you guys the trouble here. I'm going to tell you what one of the roots is. One of the roots is 1. So now I want you guys to do part C. X minus 1. Yep. So if 1 is my root, then according to the factor theorem, x minus 1 would be one of my factors. You just take the same number and change the sign. Put an X in front of it. Slap some parentheses on there. Good to go. All right. Now you guys are going to do synthetic division. So you're going to divide this polynomial by this factor to break it down to something more manageable. Since our box method failed, we're going to use long division to break it down to something easier because our traditional factoring methods failed us. Into Melanie.
X minus 1 and x minus 3.
I don't agree. Because if you had x minus 1 and x minus 3, when you multiply these in that bottom right-hand box, you'd get a positive 3, but we need a positive 4. Does that make sense? I see why you did it, though, because they do add to make 4, but what do you guys think goes here, though? It's the 2's. There you go. So, now just so you know, this answer could be written like this instead. We talked about that yesterday. But there you go. So this is a new way to factor for you guys. Up till now, you've always just had these strategies, difference of squares and box method. But now, this is actually a pretty powerful process because I could give you something really crazy like a polynomial with a fifth power and lots of terms, and you could keep doing this over and over and breaking it down over and over again, finding it smaller and smaller pieces until you get completely factored. So this always works. It's a lot of work, but it works. All right. So we're going to go ahead and continue now. Now, up till now, we've only been finding rational roots. You guys notice that all of our answers have been things like 2 or like 3 nice numbers, but can't you get weird roots like square root of 5 or something like that? You can. Okay. Well, we're going to show you how you can actually go a little bit further and get a little bit more. Okay. So we're going to, when you end up with quadratics that can't be factored, which happens, okay, we can use the quadratic formula to find the rest of the roots. So, let's go ahead and do example 2. The process is going to be very similar. It's just you're going to see something different at the end, okay? But the process to what I'm about ready to do right now is very similar to what we just did. It's just that at the end it gets a little bit different. All right. Also, I'm asking a different question here, okay? On our first example set, I was just asking you to do what? Ultimately, what were we trying to do? We're just trying to factor it, right? I'm changing the question though now, right? And now I'm asking you to find the roots. And how do you do that? Well, you factor it. And you set each piece equal to 0, right? So we're going to go that one extra step. And because we're going that one extra step, you're going to find we end up with some funny looking roots in the end, okay? So here we go. Once again, I'll save us the trouble, but you know, you want to start by looking for a GCF and then try the box method. I'll tell you both of those aren't going to work. So now we move on to try something else. And what do? We start by making a list of the rational roots. 2 can only be divided by those 2 things, and 1 can only be divided by 1. So my only possible rational roots are plus and minus 1 and plus and minus 2. That's it. And then we would go and plug those in until we found one that makes 0. And I've already done that work for you. I'm going to tell you that 2 is one of the things that if you plugged it in, it would make 0. And now we're going to find the rest of the roots. So, according to the factor theorem, if 2 is my root, then what's my factor? Yep. And if x minus 2 is my factor, I can divide that into this polynomial to factor it some more. Okay? Am I good to switch slides? All right. I'm going to need some help here. So, synthetic division time. What are the coefficients on my polynomial? 1.
-4, 3, 2.
Good. And we're dividing it, well, it was x minus 2, so we're putting a 2 out here, right? We're dividing it by x minus 2, so I'd put a 2 out there. Okay, so here we go. I know I'm right because I got a 0 there. And then we would try to factor again. And we would use the box method, right? But I'm going to save us the trouble because we don't have all day. I'm going to say that you should try to do the box method to factor that, but you're going to find that this doesn't factor. The box method fails. Okay, so you might want to make a little note of that. We're not going to do the box here. You can't. The box method only works if you could break it apart into factors that have rational components to it. But this doesn't have any rational roots. But what kind of an equation is this, you guys? That's a quadratic. Remember, we're trying to find the roots, so let's make it equal 0, right? So we're going to do x minus 2 equals 0, and we're going to do x squared minus 2x minus 1 equals 0. Now for this one, easy enough, x equals 2, right? There's one of our roots. That's one of the places where it touches the x-axis, right? But over here, if you can't factor it, how do you solve a quadratic equation that's equal to 0? No. Quadratic formula. What do you mean M? Hooray! I'm just kidding. I know it's a lot of work. This is tough stuff. All right. So, quadratic formula. This is A, this is B, this is C. So, if you're ever asked to find the roots and you have a quadratic that can't be factored, how are you going to find the roots with that piece of the factors? Quadratic formula. Okay. So, let's do it just for the heck of it, because it's fun. Right, Melanie? I mean, there's Disneyland, Magic Mountain, and then there's the quadratic formula. They're peas in a pod. All right, so what was my B term? -2? What was my A term? And that goes here too. And what was the C? -1? So this is just an opportunity to review the quadratic formula with y'all. So why don't you guys tell me some stuff here. What this is what? Now this is going to be 2, right? And this is going to be 4. And that's going to be, so you're right. So this makes -4, right? And then we have a negative here, so you have double negatives. So it's going to be plus over 2. 4 and 4 make 8, right? What do we do now? Simplify? What does that mean, though? You're right. We gotta, no. We gotta find the square root of 8. You gotta break down the 8, take out the pairs. Are we having fun yet? Come on, you know we are. What makes 8? 4 and 2? 2 and 2? Right? And so now we have in the front, what was it, 2? And now we can do what you said, Eli, we can reduce these 3. What goes into all 3 of those? 2 does, and well, 1 does, but 2 goes into them, and so you end up with 1 plus or minus 1 square root of 2, or 1. And we really don't need this one here or this one, so there's your other 2 roots, and they're not rational. They're irrational roots. Rational means like it's a normal number, like 2/5 is a normal number. They don't use normal because that doesn't make sense, but it might make sense to you. So normal number is a number that just stops. Like 2/5 is 0.4. It's just, there it is. It's a solid number. But like something like the square root of 2, punch that on your calculator, look at the decimals. It never stops. It's irrational. So factoring only works for rational numbers. Quadratic formula is how you find the roots with irrationals. Yeah.
Can you go back to the last?
Sure. Not that?
No, the one, yeah, after that. Yeah, that's.
Oh, okay. So I'm going to give you guys, I don't know, maybe on your test I'll be nice and I'll just tell you. Like I'll say, don't bother with the box. It's not going to work. Let's go on and try the other method, right? So don't bother with the box. Find your rational roots, turn it into a factor, do synthetic division, and when you get done there, don't try to factor the trinomial you have, because I'm going to tell you right now it won't work. Just go ahead and go straight to the quadratic formula to get your other roots, okay? So that's that. Sam, what did you get for part A? Oh, that's part B. Part A is where you list the possibilities.
Oh, okay. 1.2.
Good. Positive, -1, positive, -2, positive, -4. And now you know, when I give you a study guide, you'll get to practice this a little bit more. I find that this is seeming to be a little bit confusing for you guys. I'm giving you ones that are easy because these problems are hard enough. But I will give you ones on your test where that's all I want you to do is this. So I'll probably make those ones a little more interesting. But for the problems where I actually want you to factor it all the way through and stuff, I'll keep those chill just because these problems are kind of enough. Now I've already told you about B. But John, if x minus 1 is my root, John Guillen, what's the factor? Yeah. All right. And Gabrielle, at this point we would do synthetic division. And when you do your synthetic division, what did you get after you divided? Huh? Yeah.
X squared minus 2x plus 4.
Okay. If you guys want to see why she got that, you would have put this here, this here, this here, and this here. You would have put -1 out here, and you would have went through your process. You should have gotten a 0 here, and if you didn't, then something was wrong. And so this is your x squared, this is your minus 2x, this is your plus 4, and that's where she got that. Now, at this point, if you are working like a blind mathematician, not knowing what to expect, you might just try the box method here and see that it doesn't work. So at this point, we move on to the quadratic formula. So Amber, what did you get after you applied the quadratic formula to this bad boy? You what? You cleared your throat to tell me you didn't do it? I didn't do it. All right. So that's okay, Amber. All right, let's see. How about Amaya? Did you do your quadratic formula? What'd you get? One plus or minus what? You got I and then what? Square root of 3? Okay, let's see if that's right. I know this one's -1, right? So there's one of our roots. Let's see if she's right on this, because I don't know the answer to that yet myself. Let's go ahead and work it out real quick. Did anybody else get that? We got a couple people that got that. Okay, cool. Let's see what happens here. So x equals -b plus or minus the square root of b squared minus 4 times 8 times c. Yeah. So you do end up with a negative in there. So you have -2 squared, right? Minus 4 times a times c. And since this is all positive, you're subtracting a positive 16, and this is a positive 4. So you end up with negative, what, 12?
Yeah.
take out your I, right? Break down your 12, and then reduce.
Oh,
So she was right. So the other two roots are imaginary roots. In other words, this polynomial really only touches the x-axis once. The other two roots, they're worth talking about. I didn't get a chance to do those extra credit videos, but I'd like to do some. We can make this a little bit more intense.
no.
So if you're interested, when I get around to it, I'll try to do some of those. You guys can kind of see some more stuff. But that's it. It doesn't get worse than that. So, yeah.